Well, hi, good morning. Yes, good morning again. It's now May 22nd. It's been a couple days since I've been in the shop here working on this radio and attending to other things, especially outdoor stuff in the beautiful weather, but the beautiful weather is not here today. I'm left with this radio, which I'm really running out of ideas about what to do. The problem being the motorboating, and you know, what I've got in my head here, in case it's of any value, is I think there's a wiring error in here somewhere. I still do, even though I've gone over the thing and over the thing. So this morning I was thinking to myself, well, what is it? What different thing could I do here? And I came up with something I haven't done. And I'm going to do this painstaking process. It sounds kind of straightforward, actually. So these are the four sections on the switch here. And I'm just going to take each section, each wafer, one at a time, and I'm going to go around. I'm going to identify all the connections and see if they don't match this. Maybe I'll find something wrong at that point. But first, just to lighten things up before I start this, so I'm definitely not going to do it on camera. But you know, I have some old books which I enjoy reading, like Everybody's Radio Manual, How to Build and Repair Radio Receivers. I'm just going to show you, there's something in here I want to show you, but on the way there, excuse me, there's a couple other interesting things here. There's the tools you need to fix a radio. Really? I think I know how to use the small ball peen hammer. Here's your radio bench. Radio repair bench. Kind of looks like a woodworking bench, doesn't it, really? Thought that was interesting. Lots of little instructions here. How to solder. Look at that soldering iron. Whoa. I've got one like that. Should bring it out and try to use it. But what really is interesting is this in the book. This newspaper article that somebody has had in this book. Look, you can see that the color of the page has changed. It's been sitting in the book for who knows how long. This article is from 1956. Between you and I. But you know, this is not what's interesting. This is about Lawrence Welk. Yeah, that's not interesting. Lawrence Welk, for crying out loud. On the other side, though, is an article called Pill-Controlled Robots to be Men of Future. What? I'm reading that again. Pill-Controlled Robots to be Men of Future. Yes. What are they talking about there? Well, what they're talking about is something like people who take pills can be turned into robots. And they'll be the pill-controlled robots. They didn't mean robots themselves. I'm going to put that right back where it was. Pill-controlled robots to be men of the future. And I guess I'm one of those men of the future. But I am not pill-controlled. Okay, so I'm going to get on with this rather painful process. And the only reason this is going to work for me is because I discovered enough, stumbled over enough information on these sheets that I think I know what I'm doing. Great. Wow, after all this, I still don't know what's wrong with it, but I think I know why there's something wrong with it. And it just comes down to the labeling of these switch wafers. So I know there's confusion. I've been aware of the confusion here in terms of how these are labeled. How they're labeled in here. It's very hard to see. But the part that just leaped out at me just now is when you look at this, it says it's switch S2D. No, it's S2D and it's something else also, because they're showing you the switch contacts and they're showing you the switch solder terminals as if they are all on 2D, the side called D, but they're not. They're not. What they've done in here is the switch contacts are on like the D side, but the terminals are on the other side of the wafer. So when you look at this, the D can means where these switches are. But those terminals are somewhere else. They're on the back side of it. They're on the back side of it. So what I've done, because I'm interested in the terminals, I'm not interested in the where the switches are, it's all about the terminals, is, and I haven't done yet, I'm going to relabel these with the side of the wafer that the switch is on. But that doesn't even help, because it's not A, B, C, D. It's not like that. It's like this. A, B, C, D. Well, it is like that. Well, only if you look at the terminations. So if you look at the terminations, you get a simple thing, A, B, C, D. But if you look at the switch side, you get this weird thing that they're showing. Oh my gosh, I'm just going to confuse myself even more talking about it. Where they show, for instance, at the back, they show that as B. Well, it's the B switch, but the A terminals are sitting there. Oh my gosh. I think that's where the confusion has come from quite a while ago when I worked on this switch. To be a little more specific, it looks to me like I've mixed up a fair bit. And can you blame me? No, I'm not blaming me for it. Based on the way they've done this, how can you avoid getting confused? So the big thing that's standing out is that this capacitor, which is running between this section and this section, now I just put this in, it shouldn't be crossing sections. It's supposed to go from one terminal on a section to another terminal on the same section. How come it's out here? A, B, C, D, that's why it's out here. So now I got some new eyes, some new information. I think I'm going to find out that this wire probably goes all the way to A, which is why I had it all kinked up to get here. It's really wanting to go all the way to A, but I don't know just yet. So I'm going to check all this out now. New information, new hope. Hope springs eternal. Well, it's been about an hour and a half, something like that. I'm coming in here, spending 5 minutes trying to sort this out. Then my brain is saturated. I gotta stop. I come back after a few minutes and try again, and try again, and try again. And the same thing happens every time. I can trace wires about 3 or 4 steps through here following the schematic. But then all of a sudden, kabowie, it all just goes crazy. And I got too much juggling in my head. Can't sort it out. So just the direct approach of looking at it and trying to, it's not working at all. So what I'm going to try to do now is make my own diagram of how the switch is wired. I also took a look at my earlier videos. You know, this radio appears in about 60 videos. Oh my gosh. And the very earliest one I've got, the switch is already like this. So I did this work before I did videos, and I think I did this work on this a long time ago when I didn't have many parts. I may not have even had a schematic at that time, come to think of it. This would have been prior to the internet. So goodness knows what I did. I would have been replacing part for part, but there's no guarantee you're not going to make a mistake in doing that. I don't know, boy. This has really burned up way too much time in my life, but I do want to get through it. So I'm going to make a diagram. That's what I'm going to try next. See how many brain cells I lose on that deal. So what I've done is I've started out drawing the basic structures, volume control, terminal strip, and the switches. The switches have a dozen terminals on them. All of them have a dozen terminals. So now I'm going to wire it up. I'm gonna kind of do it sort of visually, pictorially. So this is not really a schematic, but more a picture. I may have to redraw this to make it more schematic, to make it look a little more like the real schematic. But I don't know. We'll see. Step 1. Okay, another hour into this guy here, and what I did is I drew out my version of how it's wired. I then sat and compared that to this. What a painful process. In the end, you see all the check marks all over the place. Nothing wrong. Everything checked out. What is going on? So, I'm reaching the end of my rope here, so I decided I would check the volume control again. So I checked that very early on. I don't know if I did it on video or not. But what I'm actually reading here is the resistance between the terminal on the back of the volume control and one end of the resistive element. I have the volume control all the way one way. As we turn it and pass the tab, we should drop to 0. 4, 3, 2, 1. And get right on top of it, this thing should say 0. And then as we keep going, so we see a bunch more resistance here. It could be because of the way the circuitry and the radio and all that kind of stuff. Let's just take a look right across the right across this guy here. That would be from this terminal right across the resistive element over to this blue one. We'll do right here. Five megohms. So let's turn the knob here. It shouldn't do anything really. It might have a little effect because it's hooked up to a circuit, and so stuff could happen. But so it's a 5 megohm volume control. 5 megohm volume control. Is it really? If we look here. Oh, don't look there. That's the wrong radio. Don't look there. Look here. Look here. Yeah, that's all I need. Start looking at the wrong schematic. Okay. So the volume control is R8. I don't know if you're going to be able to see this. Right above my thumb is R8. Well, 1 megohm is what it says there. 1 megohm volume control. No, I got a 5 megohm volume control. Is that what this has been all this time? Just the volume control resistance has gone way up, and that this would lead to motorboating? Well, could be the case. Could be the case. Now, why the resistive element has gone way up, I don't know. It seems consistent in its operation. It doesn't seem to have any burn spots in it or anything like that. So, what to do about this? How do I even know for sure this is the problem? What are the chances I have a 1 megohm volume control with a tab out the back? Just right for this radio. The chances are pretty much nil. So I got to stop now. I got to think about. So what am I going to do about this? What can I do about it? Maybe there's something simple I can do about it. Get this radio into operation. I got to go think. I rummaged through my meager collection of potentiometers here. I'm sure I don't have one with the tab on the back, and it has to be a 1,000,000 ohm potentiometer. That's a pretty hard thing to. I mean, I'd be really lucky if I had something just like that. So I think what I need to think about now is how to get around this problem, how to get along with what I got here. There could be something I can come up with. I don't know. I have a lot more volume controls to look at too, but I'm really pretty hopeless on finding a replacement. Okay, so I've been off doing a little bit of research, trying to learn a little more about what the tapped volume control is all about. I mean, I've always known it's about controlling the tone. Usually it's just done with some capacitors and stuff, but this one has feedback being driven into the tap at the back of the volume control. that's just a little different. So I actually did find something interesting about I found a patent talking about using a tap on a volume control to solve a certain problem. And now I've gone and shifted my and I tried my best to get it on my computer here so we could put it on the screen and we could look at it, but son of a gun, I couldn't do it. And I've lost my place in this document. Son of a gun. Okay. Shoot. Okay. Found it here on my phone. So I'm just going to read this section to you from a patent document from 1951. And what this person is offering is a patented way to control a problem in a reflex amplifier. Reflex amplifier. I had a radio on my bench a couple months ago, a very old one. It was using a reflex amplifier in which the RF passes through a tube to be amplified, and then the audio is brought around and passed through the same tube. So you get double duty out of that tube. That's called a reflex amplifier or whatever. It comes along with a problem of turning the volume down, which I'm not going to go into. It's nothing to do with this radio, but one solution is to apply feedback to the tap on a volume control like that. And this is what this radio is doing. And here's a statement from the patent. And so this, by the way, the volume that remains on a reflex amplifier, when you turn the volume down, you still hear something coming out, is called playthrough. That's what they like to call it. I've never heard of this stuff before, but here we go. There is, however, a limit to the amount of playthrough reduction that can be obtained with this circuit because, as the amount of negative feedback is increased, peaks appear in the response of the audio frequency amplifier, according to well-known feedback theory. And with a further increase in the degree of feedback, actual oscillation will occur. Okay. So the idea here is, you turn the volume down, you start to increase the amount of feedback. The idea back there is to control this problem called playthrough. But here, it's about controlling the tone quality. Probably providing a bass and treble boost, probably providing a loudness effect, but doing it through the application of feedback. My theory now is the high resistance in this volume control is upsetting this circuit. There's too much feedback or something of that sort is going on, and because it's just way out of balance, I'm getting an oscillation out of the set. Incurable until I deal with this volume control situation. The thing is, if I remove the feedback, we'll just take the feedback away, but we already know, and here's the feedback taken away right now. If you take away the feedback, the output is terribly distorted. So exactly what I'm going to do here, I don't know. I'm going to think about it some more. I'm going to show you something really weird about this volume control, which I noticed when I was taking a close look at it. I have no idea why it's like this. It could be from me. Okay, so here's the volume control. Here's the back of it. There's a bullet hole in the volume control. So, this could be me years ago wanting to spray some stuff in this volume control and drilling this hole. Drilling a hole in a volume control case, not a good idea because you're going to drop in a little bit of metal probably. Is that what happened? Did I do this when I was a teenager? I didn't have a drill that small when I was a teenager. I don't know. Another possibility is to disassemble the volume control. It's possible. See, it's just held together by these bent tabs. You just bend them back. But probably all that will succeed in doing is showing exactly what's wrong inside. It's not going to fix anything. And we can imagine what's wrong inside. The material that the slider slides over is worn out. It's become thin in places. Maybe it's fraying, it may be fraying or coming off. And ultimately it's a much higher resistance. Now when I started on the radio, a week or so ago, these wires were cut. But that didn't seem to solve the problem. Well, that kind of blows a huge hole in everything I just said. Yeah, that's right, man. Theories go down the drain pretty quick around here. Why don't I just nip this stuff open again and see what happens? Oh, for crying out loud. What if I nip one or the other? I nip the wire or nip the resistor. The resistor is just going to ground here. The resistor is going to ground. By nipping the wire is the real business entity here. Where is he? It's this red guy coming here. Okay, I'll go think about that just a little bit before I take some kind of rash action. That's not very rash because I can redo whatever I've undone easily. Okay, here's my crazy idea. I'm going to clip lead parallel to the wire I'm going to cut. I'm going to turn on the radio and we're going to listen to it. The clip lead in place, I'm going to cut the wire. Nothing should happen. If something happens, then I know my clip lead is causing problems, because look at it. Hopefully nothing happens. Then I can just remove the clip lead and we find out what happens when I stop the whatever it is that's making it back to this wire. Feedback or whatever it is. When I remove it, we'll know what happens. Okay. This is still hooked up for monitoring the AVC. Let's just get that out of there too. Okay, here we go. Not turned on. Not plugged in. Not plugged in. There we go. Okay, because I don't have it on full volume, full voltage rather. Okay, let's go for full volume here, full voltage. Oh, there's a quiet spot there. Why does the radio volume drop to 0 as you go by the tap on the back? Why would it drop to 0? Now it does have this resistor here. I think I know why it drops to 0. I got my answer. So this is a 22,000 ohm resistor here, and it goes to ground. Stuck right on this tab. So maybe when this was 1,000,000 ohms, this was great. But this is 5 million ohms. There's so much resistance as you go by here, you get such a high resistance that the circuit is essentially grounded through this relatively low resistor. 33K. 22K. 22K. I hate it when machines are happier than I am, but... Okay, so the experiment here, in the hopes of getting a satisfactory something out of something. Either cut the resistor or cut the wire. Hey, cut the resistor. Let's cut the resistor. Well, I set it up to cut the wire. 6 of one, half a dozen the other. I can put the clip lead. Let's cut the wire. Cut the wire. Cut the nonsense. I'm so indecisive here. Oh, let's not cut it. Put the power on. The whole idea here was to make this safe. Power off. Pull this out of the way. Okay, put this back on. Everything should be as it was. Okay, now obviously I can't control the volume too much. I'm going to turn it down a little bit here in my, turn the microphone volumes down just a little bit. Okay, tricky to put this back on. Oh, wow. Got rid of some of it. You know, that sounds like zero to me. Just don't go all the way down there. Stop here. Last time I did this, I cut the red wire and I cut the resistor. I just took everything off that tab. And in doing that, I put the volume control 0 down to the end of the volume control instead of having it shorted out up here. This time I've left this in, and without really meaning to, I've established a new 0 point on the volume control. Now let me just check the voltage here on the radio. It's 112. Let me put it up a little bit. 119. So that's pretty typical of what's in the outlets. You have a smaller 0, but there still is a 0. So the radio goes from not being usable to being usable, even in this condition. Although we don't know about the tone. We don't know about the tone. It's the tone, Jim. Yeah, let's get some signal on here. Not sure what band I'm on. Don't think I have the antenna switched on down here. Okay, yeah. Let's just play around here. There's the 0. Okay, that's broadcast. That's a whopper of a noise signal hitting this radio. I get the impression there's no bass in it. Ooh, what happens if you start fiddling around with this? Switch. That's phono. That's phono. Something up here. It has to be like a person talking or something like that. Okay, let me see if I can solve all that. Okay, the last thing I'm going to do today, so we're going to try this radio with this loop antenna. You can see it's this antenna it's listening to. The antenna is not hooked up to the broadcast antenna because the broadcast antenna input doesn't work on this radio. It's on the shortwave input. which is not where it's supposed to be, but it is. And I'm getting something. Let's listen. Well, the point of this is to check the tonal quality of the radio, and it's producing lots of bass, even though what I'm listening to is junky noise signals and some horrific heterodyne. Oh my god. I don't know, can you recognize harmonic distortion listening to things like that? Let's make a quick trip for some short wave. So we'd go 1, 2, 3. Gotta get off the this antenna again. Put on the outdoor antenna, which well, let's see what we get. Heterodyne with everything. Wow. And shortwave reception's been very poor. At least that's how it seems to me for the last. Should go up this way. For the last week or so, maybe more. I have an idea. What I did was I turned the antenna on. Good move. You can hear a station here. Unfortunately, that heterodyne is right on top of it. Oh my gosh. Oh boy. Okay. Oh man. Oh man. This is just going the wrong way all around. So there you are. That's where I am with this radio at this point. Oh man, I've got radios waiting to get in here, buddy. You got to get out. Well, thanks a lot for watching. This just seems like an endless journey. I will hunt through my more meager stock to see if I can find some kind of a replacement for that. I'm not too hopeful about it. And then it's, yeah, I did read on one of the forums that there is no way around this. If you have a radio with a tapped volume control, you can't resistor capacitor your way out of the problem if it's not working right. You have to replace it with a non-tapped volume control. You got problems. And since this radio, it's not just tone, it's the feedback too, which is going to affect the level of distortion in the signal. It's really kind of a sad situation, frankly. See ya.